We have this graph and we want to try to figure out the equation of the graph. Now, when I look at this, I see from the repetitive wave shape that this could be sine or cosine. It could be flipped or not flipped. It's your choice. That's why you have to write it down for step one, because if I'm reading your work, I need to know what function you're starting with as your parent function that you're aiming for. If I think it's one, like cosine, and you think it's another, like sine, then our answers are going to look different. And so you have to guide your reader through your thought processes along the way. And no matter whether you pick sine or cosine, then you have to decide if it's flipped or not, because that also changes the answer. If it's not flipped, you get one answer. That's even different than somebody who picked the same parent function as you and said it's not flipped. So flipped, not flipped, sine, cosine. This is why you have to make these decisions first in the first two steps. So I'm going to go with cosine, which we know has a period of 2 pi. And I'm going to choose that it's flipped. Those are our first two steps. Now we want to calculate the absolute value of A. And we know that the calculation is the absolute value of the high minus the low divided by 2. So when I say high minus low, what I mean is where is the top of the peak, where is the bottom of the valley? And in this case, I see the top is at 8 and the bottom is at minus 2. So this is the absolute value of 8 minus a minus 2 over 2. So 8 plus 2 is 10 divided by 2. The absolute value of 5. And so since I chose flipped, my A is equal to minus 5. Those are my first 3 steps done. Now I want to find D, which is the high plus the low over 2. So that's 8 plus a minus 2 over 2, which is 6 over 2, and that's 3. So I know that my A is 5 and my D is 3. And I just put some marks there to help me find them. When I want to get back to the end, I'm like, what? Where did I put the numbers? So I put the marks there. So that's step 4. Step 5 is we look for the period of this graphed function. And the idea of picking 2 corresponding points are corresponding, meaning they're showing the beginning and end of a cycle. And so you could pick the bottom of a trough to the bottom of a trough, or you could pick the top of the wave to the bottom of the wave, or you could pick any 2 points that correspond. So I could pick this point here because it's touching the x-axis, making it a little bit easier for me to read what x value it's over. And I'm picking the part where the wave is coming up from the trough. So its corresponding point is over here, the wave coming up from the trough, and I would write those 2 values down. Or I could go from this one to that one, or I could go from this one to that one. The idea is they have to be on the same part of the wave, but one cycle over, so that you can see what the whole cycle is. So I'm going to go with these 2 points. And I see that the x value of the right point is pi, and the x value of the left point is 0. So I know that pi minus 0 is just pi. That's the period of the function that I'm working with. And to calculate b, I take the period of my parent function 2 pi, and I divide it by the period of the function I'm looking at, that's pi, and I get a b value of 2. Now I want step 6, I'm looking for a horizontal shift. So one of the advantages of picking this to be cosine and flipped is that that puts the part of cosine that touches the vertical axis here on the vertical axis. That says then, because I picked cosine and flipped, that means there's no horizontal shift. If I had picked, for example, cosine and not flipped, then this could be the start of my my cycle. This part would normally be sitting on the y-axis, so I would look at the distance from 0 to wherever that value is, which looks like about pi over 2. And I would say that's my horizontal shift of pi over 2. If I had picked sine as my function and say sine and not flipped, then I want the halfway point in between, which we saw for D is 3. So I would look here, that's where my baseline would be going through. And so sine starts at on the just sine without being modified starts with this point on the baseline sitting on the vertical axis. So I would look at this distance from the vertical axis to here, which is probably about pi over 4. But because I don't have those marks, I would go down and I would read from 3 straight down, and I would say that looks to be about maybe 0.8. And I would actually use the value 0.8 in my calculation. Just like if I use this one, I would use the value that's a little bit more than 1.5. I'd say maybe it's 1.6. So you have to mark the points that you're using to calculate your H, because you could calculate your H this way, in which case it's a shift to the left instead of a shift to the right. So you need to mark which points you're using to calculate the periods and to calculate the shift. So mark them on your paper and say, or put them in your notes, this is what I'm using. Okay, so I have no horizontal shift, so that means that H is equal to 0, and that means that C is equal to 0. So I have my A, I have my D, my B, and my C. Now it's time to move to step 7, which is to write the function. So I write f of x is equal to, and I want to write down a first, so there's minus 5. I write down my parent function, so there's cos. I write down b, there's 2x plus c, which is 0, so I don't need anything there. And then plus d, which is 3. Now, on a digital test, you're not going to be able to just mark on the paper the graph that I show you. So what you're going to have to do is either do a quick sketch of the graph and say, okay, professor, this is what I have, and I use this point there, and then write the coordinates, or you're going to have to say, I used the point that had the x value, and then you would say, for like in this case, if you thought it was sine and not flipped, you'd say x equals 0.6. So you have to identify for me what points you're using to do your calculations so I can check your work. If I can't tell what point you're using, I can't believe what number you're putting in. So go ahead, since you tried this on your own before watching this video, go to some graphing software and type in what you got and see if you get the same picture. And you can also type in what I got here and see if the two graphs overlay.